My name is Catherine. I'm an architect here in Copenhagen, and one of the things that I've noticed recently moving back from the Netherlands is that in the Netherlands there's this huge bio-based movement that's going on. And when it comes to bio-based materials here in Denmark, there's very, very few that we can actually use. So when I was in the Netherlands, I would often specify products and projects made with mushrooms. Here in Denmark, we're specifying mainly pork on our facades. And I also cannot forget my favorite, seagrass. This is also a product that's on the market here. But in the Netherlands, people are experimenting with wild things. They're experimenting with using actual waste.
This toilet is an ode to local 3D printing. That means you sit on the toilet, right? You flush the toilet, the water, the sewage water is being captured. We filter it, the water goes away, and all the ingredients that we still have are used to 3D print the toilet.
They're using the dredge materials from the canals to create blocks and bricks.
And we have bio blocks from the swamps of Overijssel, which is a province in Holland. These blocks are made of the sods that cover the swamp.
There's all sorts of really cool, innovative things that are happening down there that are not necessarily really happening here at the same scale and the same level. So I wanted to investigate why. And one of the things that I've kept hearing over and over again is this story. And it's the same story every single time. And it always has to do with a certain windbreaker board. So I've heard the story, as I'm calling it, from multiple angles. I've heard it from the angles of the real estate companies. I've heard it from the angles of the business people. I've heard it from the angles of the architects, and now recently I have gotten to hear the angle from the contractors that I've been working with through my business. So now I think I have a more complete idea of the picture and how this one product here in Denmark has ruined the ability for people to take educated risks when it comes to products in general here. So if we fast forward back in time and we go to 2007, around that time period, there's this new hot board on the market. It's magnesium oxide. It's sold here in Denmark as power board, eco board, among other things. Now, what is the product? The product itself is magnesium oxide, which is actually technically chalk, formed into a non-hydraulic concrete with about 30% organic fibers added to it. So in layman's terms, this product is essentially chalk concrete plus a bunch of sawdust smashed together in a very solid product. Now, what is this product for? This product is being sold in the building markets, imported from China here to Denmark, and is being sold as a gypsum replacement. And at some point, somebody has the brilliant idea, hey, this is a very cheap product. We use this other product as a windbreaker board. It's more expensive. We can use this instead. We can save a ton of money on construction. Everyone's happy. Woo, like, let's do this. Let's go home. So what is exactly a windbreaker board, and why am I calling it that? When you have a light-bearing construction, such as a wood construction, you tend to have a board that's installed between your cladding and your inner insulation. And this is your windbreaker board. Its purpose is so that when wind hits the building, it stops and blocks that wind, but usually it's lifted by a couple of spacers with a filter underneath the construction to allow air to permeate the construction, because it's all about having a proper balance and control of the construction, getting the ventilation at the right parts. So there's all sorts of different principles of building in different countries. And as I mentioned before, this is a product that was coming from China. It was being imported into Denmark, but people hadn't really done the research on, is this an appropriate product for the building industry here? Another fun fact about Denmark, you're never more than, I think, 100 kilometers from a coastline in this country. So the relative humidity in the air is super high, which means that when I go on building sites, when I talk to homeowners, A lot of the damages and the issues I see with constructions, especially of renovations, has to do with rising damp, using the capillary action in the construction, basically sucking up like a straw all this moisture and then holding it in the construction and causing damage. There's also black mold, yummy. That tends to be an issue here. By the way, if you're new in Denmark, please open your windows even in the middle of winter, because otherwise you're going to get condensation on the inside of your windows, which is going to, yes, again, lead to delicious black mold. And then finally, in general, that's, I would say, the largest issues I tend to see with homeowners is mold and rot and, rising damp. And these are all things that are affecting a lot of the constructions here, even the ones that are built properly, because over time, water likes to find its way in. You can't really stop that, but you can slow it as long as you're building with the proper buildup of materials. Now, everyone was using this windbreaker board. What they didn't realize was that this windbreaker board contained, in essence, again, chalk, and then magnesium chloride, which is a salt, and all this organic material. So when it was installed between the cladding and the insulation, any rain that came basically pelting at these facades, of course, is going to hit this windbreaker board. Now, normally that's not a problem because what we use basically, in essence, is concrete. It's a concrete board. And so water basically hitting that doesn't matter that much. Unfortunately, when you use a non-hydraulic concrete made from magnesium oxide, it acts like a sponge. So this windbreaker board, which is installed at the most critical point for both wind and moisture, acts like a sponge. It just sucked all of the water up the entire building essentially and let it leak into the insulation layer, which would be bad, but the fact that there's magnesium chloride in the board made it 100 times worse because of the salt presence. So articles have been describing this board as crying salty tears because in essence, it just leaked all of this salty fluid all over screws, structural joists made out of steel, cladding profiles also probably made out of steel or aluminum or zinc, and just corroded the building from the inside out. So how did such a horrible product for the Danish climate come to be so widely used? It was used in huge housing projects, ones that pension firms invested in, ones that lost people a lot of money for their pension. When you're a contractor, where do you go to get your information from? You go to the building market, probably. Now, I do this as well as an architect. When the built bio-based materials first hit the market, the very first thing that I did was I went to the different suppliers that were hosting these materials and I asked them questions. How would you recommend this in a construction? What does the buildup look like? And of course, when you're an architect or a contractor, you're kind of hoping that the people selling the product have done their due diligence on how it's recommended, what the product data sheet says, how it should be used. More and more we're seeing with things like the Grenfell Tower disaster that a lot of these product data sheets are completely incomplete. There's a lot of data missing on them. There's a lot of things that are not described in them. For example, there was nothing warning related in the product data sheet for these windbreaker boards about moisture or damp or do not install in climates with over 85% relative humidity, but they don't have this information. And that is because a lot of times they do not do their due diligence. They do not test long-term the damage to your health. They do not test long-term the damage to the construction necessarily. Usually the science part, the does it actually work part, sometimes ends up happening in the buildings themselves. And so it takes about 5 to 8 years to really determine if a new building product is actually safe for the markets it's actually being sold to, which is really scary when you think about it like that. In any case, of course, it has been determined that if ultimately the contractors that have used this board in construction between, I think, 2007 to 2015, 2013 to 2015. They are not liable because one of the information articles from Bug Erfa that was published essentially listed this as a common windbreaker board that you could use, which in the minds of many contractors gave it the green stamp that this was approved material for construction. This article that was published in Denmark, they were just listing different options of windbreaker boards. So they were like, oh, you can use cement board, you can use gypsum board like this, and you can use magnesium oxide boards. Not saying you should use it, but just listing it as an option. That sounds actually worse probably now that I think about it. In any case, because of that, obviously that information is coming from somewhere. A bunch of contractors for large scale projects picked up this magnesium oxide board, installed it, and well, now millions of kroner later, we know that this is a terrible idea and a terrible solution. So if we want innovation, it's not about pushing these materials into buildings as fast as possible. It's about testing them. It's about making money and time for these tests. And it's about playing it safe as well, because I don't want to risk my client's health of their building. I also don't want to risk my contractor's liability by specifying something he's not comfortable working with. So we need to find a crossroad to that, and I'm saying that more testing, more science is definitely the way to go in that direction. Maybe it's not as glamorous as architecture, but it's definitely necessary to bridge the gap between some of the crazy things that are happening in academia with all these pavilion projects and actually getting it into the actual industry.